Dear students, in this video, you are going to see 5.3, 5.4, 5.5. Find the Lorentz series of f of z in the given region. Okay. Now, you see the first question. What is the given function? Given function is f of z is equal to 1 over z minus 1 multiply z minus 2. The region is modulus of z is less than 1. You see, which means what in the picture. Okay, modulus less than 1, which means and the center is 0 and radius is 1. Here we have less than symbol, so that here the boundary is not considered, so we consider the area what is inside the boundary. Okay, that is modulus of z less than 1. Okay, so here this is the center 0 comma 0. Now what is this? This is pole. Okay, what is pole? Look at this function. F of z is equal to z plus 1 divided by z cube multiply z square plus 1. Okay, so now here I do the factorization on this z square plus 1, so that function is z plus 1 divided by z cube z minus I z plus I. Okay, now you see what is the root of the numerator, which means here z equal to minus 1 is the root of the numerator. So this is called, this z is equal to minus 1 is called 0 of the given function f of z. Here I am writing is a 0 of order 1. Why? Because here what is the degree? What is the degree of this is 1. Okay, now you see in the denominator z cube I have. So here what is the root? Here 0. Okay, so 0 is a pole of order 3. Why? Because here degree is 3. Now here what is the value of z? Z is nothing but I, because z minus I, if z minus I is equal to 0, then z is equal to I. So that is called pole. Okay, z is equal to I is a pole of order 1. Why? Because here what is the degree? Here what is the degree? 1. So that I am writing pole of order 1. Similarly here, if you calculate this, z plus I is equal to 0, then z equal to minus I, which means z equal to minus I is a pole of order 1, because here the degree is 1 of this factor z plus I. So this is called a pole. In the given function, we have 1 over z minus 1 z minus 2, which means z equal to 1 is a pole and z equal to 2 is also a pole. So that here this is z equal to 1 is a pole and this is z equal to 2 is a pole. Okay, so now what is our question? Find the Lorentz series. Okay, how to find the Lorentz series? See, now first you apply the partial fraction for the given function. Okay, so that if you apply the partial fraction, we will get 1 over z minus 2 multiply z minus 1 is nothing but this a is 1, so z minus 2, so a by z minus 2, so 1 over z minus 2 minus 1 over z minus 1. Okay, after applying the partial fraction you will get this. Okay, so what is the next? You see the first term 1 over z minus 2. Now take this first term 1 over z minus 2. Okay, so now here what we are going to do? We are going to write the series. We are going to write the Lorentz series of the function. Okay, for that we are going to make use of this any one of the rule. Okay, or both the rules. Okay, now you see here 1 over z minus 2. Okay, how we can apply the rule? What is the important condition we have to follow to apply the rules? Okay, so now you see here 1 over 1 plus x. See the second rule, 1 over 1 minus x. Okay, see, to apply this rule here in the numerator 1 divided by here in the denominator 1 minus x. Okay, here the number should be 1 then minus x, and another condition is this value should be less than 1. Okay, then only we can write this as a summation of n is equal to 0 to infinity x power n. Okay, so now you see here what I have 1 over z minus 2. Okay, so to apply the rule 2, what I have to write? The first value should be the number. Okay, now here we have z minus 2. So what I do here, I rewrite 1 over z minus 2 as you see here. From here I take one negative sign outside. Okay, so that it will come 2 minus z. Okay, that's why I write 2 minus z. After that you see here, to apply the rule here the number should be 1. not 2, not 3. Here should be 1. Okay, so now what I do, I take 2 as a common factor. So now minus 1 here, you take 2 outside, so which means what is remaining? 1 minus z over 2. Okay, so now this is in the form of rule 2. Okay, minus 1 over 2. Okay, now you see this only in the denominator, 1 minus z over 2. Okay, now here 1. Okay, here is at minus 2. Okay, but what is another condition to apply this rule? See here 1 minus x. Okay, but this should be less than 1, modulus of x less than 1. So here we have to confirm that, then only we can apply this rule. Okay, for that you see the region what is given in the question. See, find the Lorentz series of this function, the region modulus of z less than 1. Okay, this is very important. Okay, what is given in the question, the region. Okay, now you see what is given in the question, modulus of z less than 1. Okay, so now you see here modulus of z less than 1 means I can say that modulus of z over 2 is also less than 1. See here, modulus of z is less than 1 means half of this value definitely less than 1. Okay, so that I can write modulus of z over 2 is also less than 1. Okay, so why we are writing this? Because see here what you have, this should be less than 1, modulus of this should be less than 1. Okay, that's why here the condition is given, the region. Okay, from this region I can rewrite modulus of z over 2 is less than 1. So it is required one to apply the summation rule. So that now you see minus 1 over 2. Okay, it's a constant. Then you see here in the denominator 1 minus z over 2 is nothing but, see, similar to the second rule, 1 over 1 minus x. Now here what is x? X is z over 2. X is z over 2. So that now how we can write this is equal to sigma n is equal to 0 to infinity x to the power n. Okay, here x, so I write x to the power n. Now here what is x in the constraint? So now z over 2 is our x. So that now what I do, see, minus 1 over 2 is a constant, I write outside the summation, then sigma n is equal to 0 to infinity. Here my x is z over 2, so that I write z over 2 whole to the power n. Okay, so by the second rule I can rewrite the expression in summation form. Okay, so now what I do next, you see, minus 1 I write inside the summation. Now here 2 power 1, here 2 power n I have. Okay, so I can join these two, so 2 power n plus 1 and z power n I write outside. Okay, so that the first see 1 over z minus 2 is rewritten as sigma n is equal to 0 to infinity minus 1 over 2 power n plus 1 multiply z power n. Okay, now you see the second one. You see I write the series of the first term. Okay, now I consider the second one, minus 1 over z minus 1. Okay, now what is the second one? You see minus 1 over z minus 1. Again you see the denominator to write in summation form. What I need first, I need here 1 and then here any variable. Okay, so what I have to do here now, you see minus 1 over z minus 1, I take it as minus 1 as a common factor. See, suppose I take minus outside, then minus minus cancel, so it will become 1 minus z. Understand? See, I take minus outside here, minus outside here, and then that minus will be cancelled, so that 1 over 1 minus z. Okay, this is the form of rule 2. You see here, so 1 over 1 minus x, which means sigma n equal to 0 to infinity x power n. Now you see here 1 over 1 minus z. Okay, so now what is x? Z. So that I can write like this. This is nothing but in summation form I can write sigma n is equal to 0 to infinity z to the power n, because here this is equal to x is equal to z, so that I write here z to the power n. Okay, so now you see here, before write this summation, we have to check this value is modulus of this value is less than 1 or not. Yes, this is given in the question itself. So region modulus of z is less than 1, that's why I'm writing here. Okay, so modulus of z is also less than 1, so that definitely we can apply rule 2. See, rule 2, 1 over 1 minus x is equal to sigma n equal to 0 to infinity x to the power n. This is the condition. Yes, this is already given in the question also, which satisfies here. Okay, So that now what I do for the first term, this is my summation. For the second term, this is my summation. This is nothing but series. Okay. So now what I do to write the sum of the to write the function in Lorentz series, what I do, I combine both. Okay. So now first you write this, then plus this value. Okay. So here what I do, just I substitute here. Then what I do, sigma n equal to 0 to infinity. See here in both summation, z power n and z power n is common. So that here what is remaining? Here 1 minus this one. Okay, just I combine both in a single summation. Okay, that's it. This is the Lorentz series of the given function f of z. Okay, now we see the second question. Now you see here f of z is equal to, see, I'm taking the same function 1 over z minus 1 z minus 2. Here what is the region? That is a different annulus region. Okay, which means what? See, the shaded area is in between the circle, see, 1 less than mod z less than 2, which means you see here this is the first circle, means with center 0 comma 0 and radius 1. Okay, this is the first circle. See, this is the second circle. What is the second circle? What is the second circle? Center 0 comma 0, radius is 2. Okay, what is annulus region? Annulus region means in between, see here, covers in the square. Okay, in between two circles. Okay, this is this full, it's called annulus region. Okay, we have to find the Lorentz series of the function in this annulus region. Okay, so now we have to make use of this condition. Okay, to write the terms in summation. Okay, in series. Okay, now you see here, as usual, what you do, now write this function in 1 by z minus 2 minus 1 by z minus 1 by using the partial fraction method. Okay, as we did earlier, because I'm taking the same function, only the region is different. Okay, now what I do here, I take the first term 1 over z minus 2. Okay, now 1 over z minus 2, see here what we have to do here, the number should be first, variable should be second, so is equal to minus 1 over 2 minus z. Okay, and then you take it to as a common factor. So now 1 minus z over 2. Okay, now we have to confirm z over 2 is less than 1 or not. Yes, less than 1. Why? You see here, we have to write modulus of z over 2 less than 1. Okay, if that satisfies, then I can write in summation. Okay, now for that what I do, see here, I need z over 2, modulus z over 2. So I take this part. You see here, I take this part for the first term. So modulus of z less than 2. From this I can see cross multiply this 2 here, so that modulus of z over 2 less than 1. So this is correct. So because here this is z over 2, so that I can apply in the, I can write in the summation form, that is minus 1 over 2 sigma n equal to 0 to infinity z over 2 power n by rule 2. Already we know that. Okay, now after that you write this minus 1 over 2 inside the summation, so you will get this. Okay, now what we do, consider the second term minus 1 over z minus 1. Okay, now here you take z as a common factor. Okay, why? You see here, if you take z as a common factor, what will be the remaining one? 1 minus 1 over z. Okay, now why I am taking z as a common factor? See, in the previous question I taken 1 outside. Okay, but here I taken minus 1 outside in the previous question. Now here I am taking z outside. Why? Because I have to use this part. I have to use the second, means this part. Already I used this part, so I have to use 1 less than mod z. If I use 1 less than mod z, if I use 1 less than mod z, so what will happen here? So if I take the condition 1 less than mod z, I will get 1 over z, means modulus 1 over z less than 1, what I have here, so that this is less than 1 here. So I can write this in summation form, that is minus 1 over z sigma n is equal to 0 to infinity 1 over z power n. Then I can write this inside the summation, so that I'll get, so this is the first term of the function, second term of the function, so that I substitute here summation of the first term, summation of the second term, then I combine. So this is the Lorentz series of the given function under, means in this region. Thank you.